Friends, in this video, we are going to look at problem 2924, find the champion 2. This video addresses both this problem and the previous one, problem 2923. So our plan will be the following. First, we are going to digest the requirement, and then we look at the coding. So our main purpose here is to introduce or explain again the indegree of a node in a directed graph. So with that said, let's first look at the problem statement. So here we have n teams numbered from 0 to n-1 in a tournament. So each team is regarded as a node in a directed acyclic graph. So we are also given the edges of length m representing the daj. So if we have direct edges, let's say a to b, it means that team A can beat team B. So team A will be a champion of the tournament if there's no team B that is stronger than team A. So we want to return the team that will be the champion of the tournament if there is a unique champion. Otherwise, we return -1. So here are two examples. In the first one, it's very easy to see team 0 is the champion. In the second example, we see the return is -1. The reason is that we don't know which team is stronger between 0 and 1, right? So before we move to the coding, so actually we can quickly look at its constraints. First, the number of nodes is bounded above by 100, right? The number of edges is bounded by n times n-1 over 2. So this is the largest possible edges, right? If you have a number of nodes is n, meaning that between any two nodes, we have a directed edge. So with that said, let's look at the concept. So here, the concept is DAJ. So DAJ means a directed graph that contains no cycle, right? So, but for this coding part, for this problem, so the concept that comes into play is the indegree of a node in directed graph. So here, the definition is the following. So if a node V, there are n distinct directed edges pointing towards V. So we see the indegree of this node V is n, right? So with that said, basically we can practice this concept. So this coding actually is rather straightforward. First, I'm going to initialize a dictionary. So for I in range m. So this D is a counting of node and indegree, right? So if in the final state, if we found a team that has no indegree, then that team will be the champion because it means it can beat any team. But we need to pay attention to the return requirement if there's a unique champion. So in other words, we want to make sure there will be only one team that has indegree 0, right? So with that said, let's look at the main build graph part and the logic part. So for UV in edges, right? So this means that we have a direct edge from U to V. Then in this case, so we're going to do this. So D of V is incremented by 1. So actually U is dummy, so I can just use this. So this finishes the initialization of this graph and the indegree. So now let's just find the team that can be a candidate. So candidates. So it's team for team and indegree in the items if indegree is 0, right? Then I want to do a check if length of candidates is 1, right? It means that we have a unique champion. So in this case, we just need to return candidates 0, right? And then otherwise, we just need to return -1. So this actually forms a solution to this problem. So let's do a quick test. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the cases. So here I want to point out one thing, that is the return requirement, right? So this also corresponding to this 3 lines, the coding format, because we need to make sure that there is a unique champion rather than the situation in example 2. That's why we check the length, right? If there's just one team with indegree 0, it means it can beat all the other teams in this problem setting. Then we just return that team. Otherwise, we return -1. So that's why we mentioned that. So this requirement has something to do with the return format or the coding format. So with that said, I guess that's about it for this specific video. So you're welcome to follow up and to discuss or learn more about the concepts in graph theory. Thank you.